Hi, that we continue this section, the 13.2. So now that we have the more detailed information on estimated model in logistic regression. So first one is confidence interval for beta. So that we estimated beta hat in linear regression model and also logistic regression model. And the linear regression model that we have a pretty convenient, the formula, the beta hat follows basically, okay, so if we divide this by the standard error of beta hat, this follows t distribution with degrees of freedom n minus p. So p is the number of parameters, the degrees of freedom. So yeah, maybe I would say the p minus 1 because we have intercept. So this is convenient, but the logistic regression, we don't have any theory for beta hat. So one method is to rely on normal approximation. So just the under null hypothesis of beta is equal to 0, we assume that beta hat follows the normal distribution with mean 0. So that is actually true if, I mean, approximately true if the sample size is large. So conf int.default function use this method. Then another method is to use the likelihood function. So actually the beta hat, so the distribution of beta hat may not be symmetric. So some beta hat values, some beta values have the higher likelihood. So that we define this highest point as beta hat, but may not be, this may not be symmetric, maybe this kind of distribution. So in such a case that we wanna use the, for example, the here to here as confidence interval. If this covers 95% of the cases, we wanna use this, the I would say BL, beta L and the beta U. So this interval as confidence interval. So we wanna use this likelihood function. So this is the likelihood of beta. Then we want to use likelihood function to estimate this. And this may not be symmetric around the beta hat. So if we fully think about the likelihood function, then confidence interval may be more accurate. So this is often the case, right? So suppose you have an easy exam. Okay, so what's your estimated score? 95. And sometimes we have a slightly higher score. You have slightly higher score, like 78 or even 79. Sorry, 98 or 99. But sometimes we have you may get very low score, such as 75 or 60. So the distribution is not symmetric. So if we want to estimate the 95% confidence interval, you don't necessarily, it's not necessarily the best to make interval whose center is 95. Yeah, so conf int function is more accurate, but actually it's more complicated, more the computer intensive, the procedure. Okay, so now that we see the confidence interval for beta naught and beta 1. So confidence interval for the intercept for the model that we discussed earlier is negative 1.17 to negative 0.1. And I think this is center was negative 0.64. So it's not symmetric. Actually, this is symmetric. So this is symmetric around this number. And the estimate for x is 1.27, and the confidence interval is the 0.71 to 1.83. So we use normal approximation so that it's symmetric around the center. Yeah, so to be exact, our estimate plus minus 1.96. So this is the 2.5 percentile and the 97.5 percentile of the normal distribution, which covers 95% of the case. And if we multiply standard deviation for this, standard error of beta 1 hat, then we get the exactly the same answer as this. And based on likelihood function, so confidence interval based on likelihood function is given here. So it's not symmetric around the center. So you can see that this value is the 0.047 larger. And this is 0.056, maybe larger. So if we compare those numbers with these numbers, actually that you can see both numbers are larger, but for different amount. So it's not symmetric around the center of 1.2727. So this is more accurate confidence interval, not based on normal approximation. Yeah, so next, the fitted value. The fitted values are always of our main interest if we are interested in forecasting. So given X value that we want to see the probability, success probability. So success doesn't mean the success in a real sense, but the statistical sense, y is equal to 1 is called success, even if that means the death or malignant or accident. So yeah, for example, the people want to guess the probability of heart attack based on the blood pressure. So given blood pressure, we want to know the probability of heart attack in the next year. So once you estimated beta hat, then F inverse of X beta hat is estimated probability. So you can calculate fitted value. Okay, so in the previous example of 100 observations, the fitted values are here. So remember that first 50 observations are observation with y is equal to 0, and the last 50 observations are with y is equal to 1. So first 50 observations, the probabilities are here, mostly less than 50%, sometimes more than 50%. So last 50 observations, yeah, some observations have high probability, some have low probability. So this is a balanced data with 50 successes and 50 failures, so it's fine. But if the training data, so our sample data have only 20 success cases and 80 failure cases, then maybe success probabilities are all less than 50%. That is possible. So that is called the unbalanced data. So yes, and these probabilities can be calculated by this I-logit function. So I-logit is F inverse, and this is beta naught and beta 1 hat. So beta naught hat plus, sorry, beta 1 hat X. So if we plug in all 100 X values, we can exactly get the same numbers. So we have the two different ways to get fitted values. One from automatic way, and the other just from scratch. And the fitted value, then, yeah. So this is a plot. Just for each value of X, we calculated the fitted value. Then we just connect. So then this becomes basically the curve of F inverse of beta X. Then this is estimated probability. So now if we have a new observation, we can estimate the probability. For example, the given observation X is equal to 1.5, and we don't observe Y, what's the success probability? Then we can say that the success probability is 78%, for example. Yeah, and this is the code to generate the previous figure. So basically, we use the fitted value to generate this. Actually, it looks like this is a smooth curve, but actually we plot this 100 points. So each observed X values each observed x values, we calculated the fitted probability, and I connected these 100 points. So actually, we use just the fitted value of GLM1. But the important thing is that we have to order it by order of x values. If you randomly connect, then we cannot get the smooth curve. So if you connect this first point to this point, or maybe first point to this point, then this point to this point, and this point to this point, then this does not become really, beautiful curve, but it's this kind of the messy figure. So we have to order the values, x values and also fitted values, to get this fitted curve. Maybe another way is just you set the increment x from -3 to +3 by the increment of 0.1, then yeah, you can certainly make the same figure. Yep. So in this video, that we studied two concepts. One is confidence interval for beta hat. So that is more complicated than linear model. And then the fitted value of x. We have the ready-made function. Also, we can calculate it from the inverse logit function.